Okay, problems 1 and 2 asked us to estimate the area under the graph of this and then this, two different equations. One using upper and lower sums and 10 rectangles, one using midpoint method and 10 rectangles. My preference is to use Excel, so I'm going to go ahead and just do this and bring Excel up over here. And I've got my font a little bit bigger than you'll probably have, but I'm going to call this column X, Y, delta X, and area. And if I'm doing 10 rectangles with upper and lower sums, I need 11 numbers in there, so I'm going to put borders around like so. So I need there to be 11 columns here, and I like to center everything just to make it look prettier, so I'll make that happen there. There we go. So now everything's centered. And the one other thing I want to do, instead of say round to 4 decimal places, I'm going to go right here, select the entire region, right click, go to Format Cells, and I'm going to choose Number and 4 decimal places. So now everything shows up with 4 decimal places. And with upper and lower sums, what I need to do is establish delta X. And delta X is the interval length, which from 3 to 7 is 4 spaces, divided by the number of rectangles, 10. So 0.4 is what delta X is. And I want to start at 3 and go up by 0.4 at a time. So I'm going to make that happen. So if I go ahead and type in my X column here, 3, that's my first number. For dx, I'm going to put 0.4. dx stays the same all the way through. I can just drag that down if I want to immediately. Y is equal to whatever the equation is, so y equals, and I want to type in 5 divided by parentheses, and then instead of typing x, I'm going to choose the first number in the x column, minus 2 end parentheses. So that evaluates, and if we tried it out, 4 minus 2 is 2, 5 minus 2 is, oh, sorry, 3 minus 2 is 1, 5 divided by 1 is 5, so that worked out. And the area of each rectangle is simply going to equal y times delta x. So b2 times c2. And to get each new x, I'm going to take the first x and add delta x, which is 0.4 to it. Put that formula in, drag it down. This formula's already in, drag it down. This formula's in, drag it down. In each case, I'm getting the cursor to change from this big fat white plus into this smaller black plus. That tells me I'm ready to fill. Just like that, I got the area of all my rectangles over here. The lower sum is going to be the sum of the smallest 10, which would be these 10. And I need to increase this size a little bit for it to fit. So I put lower sum equals in this column, in this cell, and then right here next to it, I'm going to put equals the sum of the smallest 10. For upper sum, that's going to equal the sum of the biggest 10. And the area is going to be the average of these two. So that's the answer I'm looking for. So if you do choose to use Excel, I would expect to see this table printed out on paper, attached to the test. Lower sum equals 7.3102. Upper sum is equal to 8.9102. Area is going to equal 8.1102. I would expect to see that information on your paper written by hand. Again, staple that to the back. That would verify to me that's the technique used, and I'd like to see the table of values that you got to ensure that everything you got was accurate. Number 2. Now we want to use midpoint method. For midpoint method, I need the exact number of columns as there are rectangles, so I want to use 10. So I'm going to delete all this stuff out. All right, and then for x, first of all, delta x. The interval length from 0 to 3 is 3 spaces, and we're taking 10 rectangles, so 3 divided by 10 is 0.3. Our first x is going to equal whatever this number is plus 1/2 of that number. So 0.15 is the first x I'm going to use. So what I want to do then is go here and I want to put 0.15 as my first x. Oops. and delta x is 0.3, and this I can just drag down to get all of them. For y, it's going to equal, it says x to the 4, so equals a2 caret 4 plus 2. Make sure the equal sign is there. And that's what that equals. And then the area is still equals b2 times c2. Type it in by hand or whatever. And this happens sometimes where you get this number that's just like that. If you just double click it, it goes more. It does have more than 4 decimal places here, so I might want to go here and redo this format cell thing. Choose number, 4 decimal places. That way it's showing up the right number of decimal places. And then finally, again, I want to go up by 0.3 at a time this way, so equals, and then I choose A2 plus 0.3. I drag that formula straight down. 2.85 is just before 3. If I went one more down, you can see 3.15. That would let you know you went too far. So you want all these numbers to be between 0 and 3. Drag this down all the way. That gets the formula going all the way down. This all the way down gives me areas. And with the midpoint method, the sum of those rectangles is the answer. So area equals, and then I just type in equals the sum of this column here. Just like that, we get 54.1957 is the approximate area. So again, I'd expect to see that on your paper. Copy or make a printout of that and staple to your test. This is just for partial credit purposes. If you have the right answer here, then, I mean, obviously all that stuff should be right. But do attach it just in case. Number 3, evaluate. And this is just a straightforward definite integral. So if I just anti-differentiate each of these objects, this would be 8x to the 4th over 4 plus 3x cubed over 3 minus 4x squared over 2 plus 5x. We're evaluating that from 0 to 4. Since it's definite, we don't have to put the plus c. Obviously, each of these things reduces. That's 2x to the 4th plus x cubed minus 2x squared plus 5x. And then, of course, we're going to substitute 4 first. So 2 times 4 to the 4th plus 4 to the 3rd minus 2 times 4 squared plus 5 times 4. If I substitute 0 in, I'm going to get 0 plus 0 minus 0 plus 0, so minus 0 altogether. So 512 plus 64 minus 32 plus 20. So 512 minus 32 is 480 plus 20 is 564. So just a straight evaluation, polynomial function, it should work similarly. If these didn't reduce, you had fractions, you had to get a common denominator, but that's maybe as challenging as I might make it. It'll be some polynomial function. It will be defined, you won't have to worry about that, does it do this or not type thing. So that should get it for us. Number 4, use the appropriate area formulas to evaluate this. If you recognize the equation, this is y equals 1/2 x plus 1. It's a linear equation, so to get the equation y, we need 2 points. I'm going to pick 2 and 6 because those are my boundaries. So if I put x equals 2 in, I'm going to get half of 2 is 1 plus 1 is 2. Half of 6 is 3 plus 1 is 4. So 1, 2, 2. And 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And just like that, I get this line. Choose the same purple, oh well, I'll just make it red. That's all it is. It's a line from this point to that point. That's the entire line. And I'm concerned with the area under the curve, so that's what we're trying to find here, is how much space is being occupied right here. And all we have to do to find that is find the area of this trapezoid. The height, or I should say this base is 2, and this base is 4, and the height is the distance between the bases, that's also 4. The area formula for a trapezoid is equal to 1/2 times its height times the sum of its bases. And just to highlight things, this 4 is that one, and this 4 is that one. So again, this 4 is the distance between the bases, that's half the height, and then 2 plus 4 is the bases. So half of 4 is 2, 2 plus 4 is 6, 2 plus 6 is 12. So the answer to this problem is 12. Number 5, we have y equals 2 plus the square root of 16 minus x squared. We've seen enough of these hopefully now to recognize that's just the top half of a circle. And the interval is going to establish whether it's the entire half or whether it's just a quarter of a circle. So if I do y minus 2 is equal to 16 minus x squared square root, it means y minus 2, the quantity squared, is equal to 16 minus x squared, which gets me to x squared plus y minus 2 squared is equal to 16. The center of the circle is 0, 2, opposite of 0, opposite of negative 2. The radius is 4 because the square root of 16 is 4. So again, if I'm just imagining this circle, center 0, 2, radius of 4, so 4 left, 4 up, 4 right. Connect those dots with a nice semicircle. That's what this graph is. The fact that this says from negative 4 to 4 tells me that I'm going to start here and end here. If it said 0 to 4, then I would only want this much of it, and I'd throw that part out. So again, the interval there is going to establish how much of the circle you're using. The equation that I'm giving you here is the entire top half of the circle, and it's the top half because it says plus. It said minus would be the bottom half. It will say plus. I don't do a bottom half circle on these tests. So it'll be a top half, and not plus there, but sorry, plus here is what makes it the top half of the circle. So the fact that we're going from negative 4 to 4 means starting here, ending there, getting the whole thing. 0 to 4 be just that part. Negative 4 to 0, just this part. All right, so whatever it tells you is what we're doing. So the interval is important to that extent. And the fact that it's risen up off the x-axis by a little bit just means that we have a rectangle attached to this semicircle. So we have a rectangle, dimensions of 2 and 8. And we have a semicircle, radius of 4. So if I'm trying to find the area of this thing, area is going to equal the rectangle area plus half a circle. And the circle radius 4, so pi times 4 squared is 16. Whole circle, half circle, we take half of that. So we end up with the overall area of this thing as 16 plus 8 pi. And that'd be the exact answer if you wanted to approximate it. 25.12, I believe. So 41.12, but I'd be fine with the pi answer. Number 6, appropriate area formulas to evaluate this. Absolute value bars. If you take 2x minus 4 equal to 0, that means 2x equals 4, so x equals 2. At x equals 2, there's a sharp turn. And the fact that 2 lies within this interval means that that's important to me. So what I want to do is I want to do x and y. I'm going to put negative 3, 2, and 3. End point, where the thing equals 0. All right. So those are the important values for an absolute value function. So all I have to do is evaluate this for each of these numbers. So if I put negative 3 in, I'm going to get negative 6 minus 4 is negative 10. The absolute value bars make it positive. 4 minus 4 is 0. 6 minus 4 is 2, make it positive. So negative 3, 10. 2, 0, and 3, 2 are all points on this graph. And then we just connect those dots with nice little line segments here. So from here to here and then back up again. And then if I were to draw straight down to the x-axis, you can see we've created 2 triangles here. Triangles have area formulas that we're going to use. So for the bigger triangle, 1, 2, 3, 4, 5 is the base and 10 is the height. For the smaller triangle, 1 is the base and 2 is the height. So the answer is just the sum of the areas of these 2 triangles. 1/2 times the base times the height plus 1/2 times the base times the height. 5 times, half of 10 is 5 times 5 is 25. Half of 2 is 1 times 1 is 1. 25 plus 1 is 26. So 3 problems in a row, just graph the figure and use an area formula to evaluate the area of that, and then That's the answer to the problem. Number 7, evaluate this, explain why it does not exist. I'm going to do the same thing on the test. There's going to be 4 of these where it says explain why it does not exist. One of them will not exist, and tell me why. If you don't tell me why, you don't get 5. I'm going to probably give you 3 points for saying it doesn't exist and 7 points for explaining why. So make sure that you actually explain yourself. An explanation, simply tell me the mathematical reason why. In this case, it's x to the negative 5th is 1 over x to the 5th. And 0 is within this interval, and if we have 1 over 0, we get an undefined. So this does not exist, and the reason why is division by 0. Other reasons why things wouldn't exist is square root of a negative number. Tangent of pi over 2 is an undefined tangent. So if it's a trig function, tangent, cotangent, secant, cosecant, where it's undefined, that could happen. So, but in this case, it's division by 0 because that happens. So here's another situation that does not exist by division by 0. Let's go from 6 to 10 of 1 over x minus 8. 8 is in this interval. 8 minus 8 is 0, division by 0. It does not exist because of division by 0. So again, anything that creates a denominator of 0, you should ask yourself, does that number lie within this interval here? If it does not exist because of division by 0. Number 8, evaluate this, explain why it does not exist. Obviously it will exist because I said only one will not, so everything else should work at this point. We have x to the 3/2 power, and we're going from 0 to 4. A half power is a square root. Square root is 0, all the way through square root of 4 is legal. Square root of negative numbers would be illegal. So if this said -1, that'd be it does not exist because square root of a negative number. That's another situation. But again, 0 to 4, this is valid. So x to the 5/2 over 5/2, same as times 2/5. So just anti-differentiate it correctly. Increase the power by 1. 3/2 plus 1 is 5/2. Divide by the new power. Divide by fractions. Multiply by reciprocal. So I get 2 times 4 to the 5/2 over 5 minus 2 times 0 to the 5/2 over 5. Obviously this equals 0. The square root of 4 is 2 to the 5th is 32. So 2 times 32 over 5, which makes it 64 over 5. Number 9, secant squared. Our 6 trig functions, we have sine of x. Antiderivative of that is cosine of x, or negative cosine of x. Cosine of x, its antiderivative is positive sine of x. Secant squared of x, its antiderivative is tangent of x. Cosecant squared of x is negative cotangent of x. Secant x, tangent x, its antiderivative is secant of x. And cosecant of x, cotangent of x, its antiderivative is negative cosecant of x. Know these answers. So these 6 trig functions have antiderivatives. If the antiderivative is a cofunction, you put a negative on it. So what I'm saying is the secant squared one, so I see secant squared. Once again, where is secant squared undefined? It's undefined at pi over 2. It's undefined again at 3 pi over 2, and so on. All right, pi over 3, if you just imagine a unit circle, pi over 6 is here, pi over 3 is here, pi over 2 is right there. So we're looking at this interval right here, obviously not going to the undefined situation there, so it's not undefined. So secant squared antiderivative is tangent of theta. We're going from pi over 6 to pi over 3. So we have to evaluate tangent of pi over 3, subtract tangent of pi over 6. The tangent of pi over 3 is the square root of 3. The tangent of pi over 6 is the square root of 3 over 3. That's the square root of 3 over 1, so 3 times the square root of 3 over 3 minus square root of 3 over 3 makes 2 times the square root of 3 over 3. Finally, number 10, sine. The antiderivative of sine is cosine. And since it's a cofunction, it's negative cosine. For sine and cosine specifically, you don't have to worry about the undefined because this is never undefined. So that interval is going to be fine no matter what it is. But again, antiderivative of sine is negative cosine. Make sure that minus sign shows up. And I simply have to do the opposite of the cosine of 3 pi over 4 minus the opposite of cosine of pi over 4. Minus minus makes plus. So I get negative, this is negative square root of 2 over 2. That's what the cosine of 3 pi over 4 is. And the cosine of pi over 4 is square root of 2 over 2, positive. Negative, negative makes a positive, so I get square root of 2 over 2 plus the square root of 2 over 2 makes 2 times the square root of 2 over 2, better known as the square root of 2.